And IPv6 multicast addresses starts with port 3. Okay. Then yesterday we discussed about unknown unicast. See here, this is an example here. Okay. This is a switch. Okay, there are 8 ports on the switch, and some devices are connected to that port. And you can see the switch receive a frame with a destination MAC address. This one, okay, 00AA. Okay. And see, the frame has source as well as destination MAC address. So the frame that switch is receiving is a unicast frame. But if you look at the MAC address table of the switch, okay, it doesn't have that information. So what it does, it will send a broadcast. Okay, the same frame will be replicated and sent to every other port, except the port on which the frame is received. The port will be sent to everyone. Okay, this is what we discussed yesterday. Okay, and this is the diagram to support that. Okay, this is called unknown unicast. Okay, again I repeat, unknown unicast means the frame has both source as well as destination MAC address, but that information, destination MAC address information, is not there in the MAC address table of the switch. You can see here, this is the packet or the frame it is receiving, the switch is receiving on port number 3. Okay, and this is the destination MAC address. And if you look at the forwarding table, the CAM table or MAC address table, okay, this information is not available with the switch. So what switch does, it will replicate this to everyone except the port on which it receives. Okay, it will send to all other, okay, all other ports in the same VLAN. Okay, this is an example of a broadcast. Okay, broadcast domain. So let us today discuss about VLANs. Okay, see, if you look at any switch, whether it is a packet tracer or, okay, there are some things which I can show in packet tracer which is not possible on both GNS or EVNG. Okay, I will show what we cannot do in, okay, GNS or packet or EVNG, that we can do in a packet, okay, in your packet tracer. See here, by default, all the ports of a switch are in VLAN 1. Okay, means this is a broadcast domain. What is a broadcast domain? Set of devices that are present in a VLAN is called broadcast domain. So here is an example of a broadcast domain. For example, all these ports are in same VLAN. Means any devices connected to this port, whether in same subnet or different subnet, if it generates a broadcast message, it will be sent to all other devices. Okay? That is called broadcast domain, and the broadcast domain can span multiple switches. For example, let's say I have some switches here. Okay. By default, all the ports are in VLAN 1 or any VLAN. I'm giving an example with VLAN 1. Okay. Suppose I have a device here in VLAN 1, another device here in VLAN 1, another device in some other switch in VLAN 1. Suppose this PC0 generates a broadcast message like ARP message. Okay, that will be sent by this switch to all the ports. This switch will receive and it also will do the same thing. Okay, so this is called broadcast domain. So broadcast domain can span multiple switches also. Okay, so why VLAN is created? To segregate the broadcast domain. Okay, to divide a broadcast domain into multiple manageable smaller broadcast domains. By default, you can see here all the ports are in a same VLAN 1. Okay, so if any of the port, any devices connected to this port generates a broadcast message, all other devices, whether they are in same network or different network, same subnet or different subnet, they will receive a broadcast frame. Okay, and broadcast frame cannot be dropped at NIC level. Okay, the device has to process it at CPU level. Okay, whenever device receives a broadcast message, it has to be processed at CPU level. Okay, let me show you an example of that. Look here, this is a unicast frame, okay, which is received by all devices, and those who are not interested, they will not receive the unicast. Multicast means this is an example of a broadcast. You can see here. Okay, I'll expand. See here. Okay, out of this 6A to F okay, pieces, one of the device is not interested in the feed it is receiving. Okay, because it is a broadcast message, it has to process it. Here, look here. Broadcast packets discarded after CPU processing. Okay, whether the user is interested or not in that packet, it has to accept the packet and process at CPU level. Okay, that's why broadcast is considered as bad. Clear, everyone? Whereas if it is a multicast packet, see here, multicast will be discarded at NIC level only. CPU is not involved. Okay, is this clear, everyone? Online? One. Okay. So today we'll start with VLANs. Okay.
Just like I have a question.
Yeah.
So you told us each VLAN will have a separate broadcast domain.
Yes,
If I have
yes.
10 VLANs, I'll have
There
10
will be 10 broadcast domains. Yes.
Correct. So, but can what I mean is, if can host in VLAN 10 can send a broadcast message
broadcast boundaries is limited by VLAN.
Correct.
The purpose of creating VLAN is to segregate the broadcast, to divide the major broadcast domain into smaller manageable broadcast domain.
Okay.
Okay, but however, even with VLANs, okay, the broadcast domain can expand multiple switches, can extend to multiple switches. Like example, let's say there are some devices here in VLAN 10, VLAN 10, VLAN 10, and there is a broadcast message for that. If the links carries VLAN 10 information, the link between the switches carries VLAN 10 information, then your broadcast domain can be extended. Okay, broadcast domain cannot cross a layer 3 boundary. Suppose there is a router connected here. Okay, let's say for an example, there is a router here. I'll remove this part. Okay, let's suppose both are VLAN 1. Both of them are in VLAN 1, and there is a router in between. Okay, let's say both are VLAN 10. Okay, if broadcast frame from one segment cannot cross into another segment. Okay, a broadcast frame cannot cross the router boundaries. Clear? So it will be propagated within this domain. Whatever the device is connected here, they will receive, but it cannot cross a router. Okay, is this clear, everyone? Okay, now let us start VLAN. What is a VLAN? Anyone? Anyone? Any idea what is VLAN? A VLAN is a group of end stations with a common requirement. Okay, this is Cisco's definition for VLAN. One of the books from Cisco, the official book, This is the definition. Okay, independent of their physical location. Okay, they may be in different switches. That is called a VLAN. And what are the characteristics of a VLAN? An independent LAN. Each VLAN is a separate broadcast domain and a logical network or subnet. Means each VLAN is associated with a subnet. Like let's say I have VLAN 10. All the devices in the VLAN 10 is considered best practice. Okay. Let's say we have given a subnet 192.168.10.0/24. So all the devices in VLAN 10 will have this subnet. Okay. Suppose we create another VLAN, let's say VLAN 20. Okay, we can keep a different subnet for that. 128, okay, 192.168.20.0/24. Okay. By default, different VLANs will not communicate. Okay, we need to make them communicate by using a layer 3 device. Okay. Now, how VLANs are created? Okay. VLANs can be created with one of these three methods. Either through global configuration mode, interface mode, and there is one more mode which is deprecated now, not used, called VLAN database. We'll see all the three modes. And VLAN information is stored in flash memory. Okay, all the VLAN information is stored in flash memory with a file called VLAN.dat. In a file called VLAN.dat. Right now, if you look at the packet tracer flash, here this we cannot do in GNS or even. That is why I'm using packet tracer to show that file. Okay, if you look at my flash right now, there is no VLAN.dat because we have only a default VLAN. Okay, once you create a VLAN, you see automatically a file will be created. Okay, so what is VLAN? VLAN is a 12-bit identifier. Okay, and it is written in decimal numbers, these numbers, right? So it goes like this: 12 bits means 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. Okay, this is your 12-bit identifier VLAN. Okay, the minimum is 0. Okay, 0 to maximum is all ones. All ones means if we add all the bit values, it will be 4095. So this is your actual range of VLAN, 0 to 4095. Okay, VLAN 0 is reserved VLAN. It is used for special purpose traffic, so for priority traffic for IP phones. We will come to that. Okay, if you look at here, there is a VLAN called VLAN 0. You will not see in the show command. Okay, it is used to carry IP phone priority traffic. Okay, I'll come back to that. VLAN 0 is reserved for 802.1p. Priority based is 1p. Okay, VLAN 1 is the default VLAN. Okay, default VLAN also it is By default, it is a native VLAN also. We'll talk about native VLAN. All the control plane traffic will go through VLAN 1. Control plane traffic like STP messages, UDP, STP messages, DTP, CDP, LACP, all these messages by default, okay, uses VLAN 1. Then we have VLAN 2 to 1001. They are called normal VLANs. Then we have VLAN 1003 to 105. They are reserved VLAN for non-Ethernet technologies. Like example, you can see here. If I type show VLAN, okay, VLAN 1 is Ethernet, ENET is Ethernet, and from 2 to 5, okay, they're not Ethernet. Some other technologies like FTDI, token ring, and others. Okay, they are not Ethernet. Okay. Then we have a extended range from VLAN 1006 to 4094 is extended range. Within that range, we have some reserve VLANs also. I'm going to show that. Okay, and then we have VLAN 4095. VLAN 405 is reserved, okay, for connecting to virtual switches. Suppose your switch is connected to a VMware box, example. Let's say this is your switch and your switch is connected to, I'll use this as a, let's say this is a VM box. Okay, there are a lot of VMs, EXI server, and on the switch side, there is a trunk port. Okay, let's say this is trunk port on switch side, but on VMware, there is no command like to configure a port as trunk port. Okay, so what it does, the port number 4095 will be configured here on this port so that it can carry tag traffic. Okay, so this is used for special purpose when you are connected to virtual switches. See, VM box has virtual switches. Okay, to connect to virtual switches to carry the tag information, this special VLAN is used. Okay, and then there are some reserve VLAN, internal VLANs. Let's show that.
Ishak,
Yeah, go ahead.
so you told right now 4095 is reserved for VM connections, right? So
Yeah.
this will be configured in the VM server side or in our
server side. Our side, on switch side, we have to configure trunk link. There is no command for configuring trunk on a VMware machine.
Understood.
Okay, so we have to assign 4095.
Understood. Thank you.
Yeah, all the control plane traffic uses by default need to this VLAN 1 default VLAN. Okay. So VLAN internal usage. Okay, there is one more range called internal usage. Okay, range reserve VLAN. See here, by default, this is a multilayer switch. Okay, there is a port here G0 by 0. All the ports by default on a switch is L2 ports. Okay, L2 port means you cannot assign IP address. Any L3 operations cannot be done on L2 port. It is purely a L2 port. Okay, if you go to 0 by 0, if I try to assign one address, it will not accept because by default it is a layer 2 port, switch port. Okay, but on multi-layer switch you can convert, you can change the port from switch port to routed port. Routed means L3 port. How? By using this command no switch port. If you use this command no switch port, it will change the port type from switch port to routed port. Let us see. Do show interface G0 by 0. Now if you see, switch port will be disabled. It is now a layer 3 port. Okay. Now it can accept any L3 activity. Okay. But if you see behind the scene, do show VLAN internal usage. Okay, see here, this port is assigned a reserve VLAN. Okay, there is a range for reserve VLAN. We can change that range also. VLAN internal allocation policy. By default, the policy is ascending. Okay, by default, the policy is ascending. If you change it to descending, then it will start giving a set of VLANs from 4094 onwards. Okay, by default, the order is ascending. Whenever you create a, okay, you change a port from L2 to L3. Okay, port number will be assigned from the reserve VLAN. Okay, then suppose you change the policy to descending. Okay, and now I configure one more port 0 by 1 as L3 port. Now if you see here, do show VLAN internal usage. See here, start assigning the port from the descending order. Okay, clear everyone? On a multi-layer switch, okay, these internal usages VLANs are reserved for internal usage. There is a set, okay, I don't remember exactly, there is a set of 20 to 30 VLANs.
What is the advantages of keeping like internal VLANs?
Internal VLAN is for internal usage also. Okay, internal usage, and also you see here, by default your ports are L2 ports. Okay, it is kept for reserve. Suppose you want to change the port multi-layer switch, okay, port can be changed anytime from L2 to L3. Okay,
Correct.
so even L3 needs a, okay, internally it needs a switch VLAN. Okay,
Okay.
right.
Okay.
And also there are internal functions. Okay, for that it is reserved. Okay, so this is about VLANs, and VLAN 0 is reserved for IP phone traffic. Yeah, see, whenever you want to assign an IP address, you want to convert a port from L2 to L3, like suppose this switch you want to connect to a router and you want to configure some routing protocol. Okay, example, anything like this. Okay, you want to use a port as L3 port. Okay, this will act as a gateway, example. Then you can use this one. You want to configure OSP, VHDRP, any dynamic routing protocol. Okay, for any L3 operations, at any time you can convert a L2 port into L3. Okay, it's not for a specific operation, for anything. Anything you want to configure, you can use it as a router. If you convert all the ports, it will act as a router. Okay, by default, but multi-layer switch is both router plus switch. Okay, it has both capabilities. Now, if you want to change it back, the command is no switch port. Switch port. Okay, like I want to revert it back to L2, then switch port is one option. There is one more option. See, there is no L3 switch. L3 means router. Okay, L3, there is no switch called L3. Okay, L3 is a router. L3 is a router or a router or firewall. They are called L3 devices. Switches are L2 as multi-layer. They can be L2 or L3. They can be purely L2, which doesn't support L3 operations, like the one here I have. Okay, for example, I'll take a switch which is purely L2 port. Okay, it cannot be converted to L3. So it depends on only multi-layer switches can be changed from L2 to L3. See here, this is purely a L2 port. I cannot use that command. Not good.
But can we call a multi-layer switch as a L3 device?
L3 plus L2. Okay, it has both capabilities, right? If you want, you can use it as L3. It supports everything. You can create okay. Same, you can do any kind of L3 operation. Okay, it is called. It has a name, multi-layer switch. It has both router processors as well as switch engine. Okay.
Ishak, like
Yeah.
you mentioned, for control packet, it will be always VLAN 1.
By
So let's
default, yes.
suppose if, yeah,
By
okay. So
default.
okay. So when we are defining OSPF for EIGRP, so we have a L3 interface. So in that case, how
L3
it will
also
use?
carries. See, L3 also supports. Okay, See, when L3 is connected to L2, okay, at that time it carries the VLAN. So L2 to L3 to L3, there is no VLAN concept, right? When you are
Yes.
connecting to routers, let's say you are connecting router 1 with router 2, is there any routing concept there? Switching is there. Suppose I am connecting router 1 to router 2. Both sides your ports are L3 ports. So
L3,
there is no
L3,
VLAN
yes.
concept, right? Suppose you are
Yeah.
configuring a router, you are connecting a router to a switch, then you can put this port in some VLAN, right? Or you can configure sub interfaces, right? Then only
Yes,
VLAN comes
right.
into picture. Okay,
Okay. Okay.
right. See here, this is our L2 switch. Okay, I'm trying to change the type here, it will not accept. Okay, because it is purely L2 switch. Okay, multi-layer means it supports both. Okay. Okay. Now, see, as I told you, there are two methods of reverting back to switch port. One is by giving switch port command. The other one is this command. This is applicable even on router also. Default interface, any interface name. If you type this command, default interface number, it will set the interface to factory default. Okay, whether it is router or switch, any device. If you use this command default interface number, it will set the port or interface to factory default. Okay, clear everyone? Now the communication rule by default, before that, how to create VLANs also. There are three methods of creating VLAN: from global configuration mode, VLAN, VLAN number. Okay, whatever VLAN number you want. Like example, you have anything extended or normal VLAN. For example, let's say I'm creating a VLAN 10. Okay, then you have the option, you can give a name, like I'm giving a name called sales. Okay, then it will create a VLAN with the name sales. Suppose I create another VLAN 20 and have not given any name, then by default it takes the name of your VLAN 0020. Both VLAN number and name should be unique. Okay, do not accept the same name if it is assigned to some different VLAN. Okay, let me show that. Another method of creating VLAN is you can create VLAN as a range also. Like I want to create VLANs from 10 to 15, I can use this command. Okay, it creates the VLAN with default names, numbers. Okay, like for VLAN 10, it will create VLAN 0010. It will use this name. Okay, the names will be like this. Okay, for 11, it will be 11 till 15. Okay, it will create like this: 11, 12, 13, 14, and 15. Later on, if you want, you can change the name to whatever you want. Name you cannot give. That's what I'm saying. Okay, name you cannot give for all the 5 because name is also unique. Okay. Separate. Again, you have to go to inside the VLAN. Like you want to change the name from VLAN 10 to some name. Okay, so you will go to the VLAN. Like, okay, VLAN 10, and then you'll give a name, whatever name you want. Okay. So let us see this VLAN creation from global configuration mode, either on multi-layer switch or okay, anywhere. So I'm going to create a VLAN 10, name sales. Okay, a VLAN is created. Okay, VLAN 20 without name. Okay, it will give a default name. Do show VLAN brief is the command, verify. Okay, VLAN 10 with a name sales, VLAN 20 with a default name. Okay. If you want to create a range of VLANs, VLAN 100 to 102, okay, 3 VLANs will be created with default. VLAN, okay, let us see. Do show VLAN brief. Okay, you can see here 3 VLANs are created with default name. Okay, then I'll show you something which we cannot see here on okay, Let me show here. See here, show flash. By default, there is no VLAN.dat file. Okay. Once you create a VLAN, like I'm creating a VLAN here also, 100. Show flash. Okay. VLAN.file is created here. Okay. This is the file that carries the VLAN information. This is VLAN database. There is no file here. For user-defined VLAN, VLAN.file will be created in Flash. Okay, that we cannot see on switch. Okay, on GNS or I've tried, but I did not saw it. Okay, clear everyone? Now my question here is: suppose there is a reload. We are not saving this, and there is a reload. Okay, suppose there is a power failure or a reload happened. What will happen to the VLAN which we have created? We have not saved the configurations. Anyone? Very simple question. Okay, what will happen to the VLAN which we have created? Suppose we have not saved the configurations and there is a power failure or reload of a switch. What will happen? Anyone online? Okay, whatever be the answer, correct or wrong, anything. Will the VLAN stay or it's gone?
Will be stay.
Yeah. The reason, what could be the reason? You're right, it will be there. The reason because it is stored in flash. Okay, flash and NVRAM is permanent memory. RAM is volatile. Okay, anything RAM is volatile, so if it is not saved, the contents of the RAM will be lost. Okay, right. Now you see the second method of, so you can see here do show VLAN, the VLAN information will be there. Okay,
How
at
to
any point,
delete a VLAN.dat file?
can you repeat again, Arun?
So thing is, sometimes in live production, what happens, right? Once we clear the NVRAM and the startup
That is in
config,
flash.
still,
If it is deleted, then it will go. If you have deleted the
but
file,
still that VLAN.dat file will be there after clearing NVRAM also.
it is in
Is there
flash
a-
memory. It is in flash. You have to erase that one. Okay, just like you have your iOS. It is with iOS, right? Your flash is okay. Stores iOS also. This is your iOS operating system file.
Correct.
Okay, so both has to be deleted manually. Delete it, then it will be gone.
Okay.
By default, once you create, it is like DDL command. If you anyone has a DML DL command, okay, DDL means permanent. Okay, no commit is required. Once you create, it is saved. DML means you have to commit, you have to save.
Okay.
Right. Now let us see the second method of VLAN creation through the interface method. Okay, interface mode. Okay. Okay. Let's say I want to add FA0/1 in VLAN switch port access VLAN. Let's say some number at least 200. Okay, what this command does, see VLAN 200 does not exist right now. Okay? This command does two things. It creates a VLAN by the name which you have given here with the number whatever you have given. Also, it will put this port in that VLAN automatically. It does two things. Okay, let us see. Then I will ask one more question. VLAN, no, sorry, I want to use interface mode. Interface FA0/1 switch port access VLAN 200. Okay, it says access VLAN does not exist, creating VLAN 200. Okay, VLAN is created and also the port will be assigned to that VLAN. If you look at the do show VLAN brief command, okay, VLAN is created and the port is assigned to that VLAN. It does two things. Okay, now at this moment again there is a reload and you have not saved the data. What will be the outcome? Anyone? Any guess? Right or wrong? Anything, please. What will happen? We have created the VLAN, okay, through interface mode, added the interface to the VLAN, and there is a power failure or reload. and you have not saved the configurations. What do you think will happen?
Will be removed.
Will be?
Removed.
See, VLAN will be there. Okay. VLAN because VLAN information is saved in VLAN.dat flash memory, whereas configurations are saved in RAM, running configuration file. Okay, until you save, it will not be moved to NVRAM. Okay, this is the reason you can see the port. Okay, assignment has gone. It is gone back to the VLAN 1. Yeah, correct. It's right, it's correct. Okay, so I'll again add. Okay, before that, okay, we'll add switch port access VLAN 200 is already there. I'll give some other VLAN. Let's see. Okay. Now look here, dir NVRAM by default. Okay, I don't have any file in NVRAM. I save the configuration either with write command or copy run start. Okay, dir NVRAM. Now I have a startup file. Okay, our configuration is also saved, and VLAN anyway saved in flash memory. Okay, now at this point, if there is a reload or power failure, both will be there. Okay, right. Now next, suppose I want to add a set of VLAN same type, okay, to existing VLAN or non-existent VLAN. Okay, then we can use the command called range to add a set of ports to a particular VLAN. Like example, let me add 2 to 5 and then 8 to 9. I can give any kind of combination. Okay, then port number 11, switch port access VLAN 10. Okay, this command puts all these ports into VLAN 10. Okay, so range command can be used to add a set of ports into a particular VLAN. Okay, now if you look here, okay, both the information is there. Okay, VLAN is also there, port assignment is also there. Now let us see this range command. Interface range FA0 2 to 5, comma FA0, let's say 7. Okay, then I will use another range 11 to 13, any range. Okay, switch port access VLAN 10. Okay, 10 was not there. It created the VLAN and also it put the ports in that VLAN. Okay, do show VLAN brief. See here, all these ports are in VLAN. Right now, on my switch there are 3 broadcast domains. Okay, see, until you assign a port to the VLAN, okay, the broadcast domain will not be active. Right now on my switch there are 3 broadcast domains. Okay, if I have devices, even if it's from same subnet, okay, in different VLANs, they will not communicate. Okay, this is a separate broadcast domain. Any broadcast message will be received by all these devices. This is a separate broadcast domain, and this is a separate broadcast domain. Okay, clear everyone? All the active VLANs, if there are ports in it, okay, there is a broadcast domain. Separate VLAN, the interface is the broadcast domain. Okay, and let us see the third method, which is not recommended. Okay, let us see that method through VLAN database. Maybe the newer switches do not have this command. Okay, this is from VLAN database. VLAN database. Okay, you can create a VLAN example. Let's say VLAN 2000 with a name. Okay, and you, let's say this is for IT. Okay, show VLAN. So you can see the VLAN 2000 is created with the name. This is the third method of creating. This is not used, not recommended also. You can see here a message somewhere. Okay, it is recommended to configure VLAN from config mode as VLAN database mode has been depleted. Okay, this is the advice from Cisco not to use this method. Maybe the newer iOS will not have that. Okay, so but you should notice, suppose you are working on a old switch. Okay, this is another method. Okay, VLAN database, the command is VLAN database from privilege mode. Okay, it should be from the or whatever you are doing so far is from global configuration mode, but for VLAN database it is privilege mode. Okay, and then VLAN number, and whatever name you want you can use. Okay, now the communication rule. Everyone clear with this VLAN? Any questions? Anyone online? Yes, I'll just repeat what we did so far. Okay, we discussed about what is VLAN. Okay, what is VLAN? Where the VLAN file is saved. Okay, VLAN is 12-bit identifier. This is the range of VLAN 0 to 4095, and these are their usage. Okay, then we saw the internal. I have not noted that one. Okay, that internal I'll add that one also. How to, okay, yeah, I'll put here for that. Okay, to change the port type from switch port to routed port on a multi-layer switch. The command is go to the interface, any interface. I'm giving an example. Okay, no switch port. Okay, to revert back to switch port, to change it back to switch port, okay, to change from L3 to L2, okay, the command is switch port. Okay, there is one more command to put the port into default state, or to clear the configurations, or you can say to set the port to factory default, to set the port to factory default, whether it is L3 or L2. On a router also you can use this command. Okay, default interface number. Okay, this is the command. Then we discuss about the internal usage. Okay, let me show that again. I have not noted that. Okay, interface G0/3, no switch port. Do show VLAN internal usage. Okay, this is the command, and this is the output. Okay. By default, we have changed the method. By default, it is ascending order. If we change it to descending order, and the command for that is VLAN internal usage. See here, one thing I forgot to tell. Suppose I want to add a VLAN 409. Okay, let's say I want to add a VLAN in the port 4094, which is internal usage. Okay, switch port access VLAN. I'm trying to add a port to a internal VLAN. See here, creating VLAN 4, but you can see here it tried to create the port but stop. Okay, due to VTP error. It is not allowing because of VTP error. Okay, external VLAN in use. The VLAN is in use. Okay, because the VLAN is already is used internally, you cannot use it for assigning anyone. Okay, so reserve VLANs, reserve. So if you are already, when you can change the policy, suppose you are already used the okay VLANs, set of VLAN ascending, so you can change the policy to descending. Okay, how to change the policy? VLAN internal usage, internal allocation policy, sorry, allocation policy. Then you have the choice here, either it can be ascending or descending. This is the command. Okay, move this one. This
Is a way to remove a particular VLAN from internal VLAN.
yes, of course. Yes, this is the only way. We change the policy. We'll see. Like example, I want to use 4094. Let's see. Okay, what I can do, I'll go to the port, whatever port I have assigned, what was the port there, 0/3, and say no switch port. That will be released. Okay, let's look now. Do show VLAN internal usage. Okay, it is not gone. We have to do a reload perhaps. Okay. When you do a reload, maybe it will go. Okay. Or change the policy. We have changed the policy already, right? Now let me try to assign again the same port to, okay. Did I convert it first? No switch port, okay. Yeah, it's no switch only. Let us see. I should move. Okay. Let me assign it to, okay. I'll make it switch port, okay. Actually, it should be switch port. I have been a wrong command, sorry. It should be switch port, okay. But because it I typed this command was in 094. Okay. Now I make it back to L2 port. Okay. Do show VLAN internal usage. See, that is gone. Okay, it is temporary as long as just like your VLANs. When you assign a VLAN, once suppose you deleted a VLAN, okay, the interface is returned back to the default VLAN. Okay, like let us see. Let us try to remove one VLAN here. VLAN 300. I have a port F0/1 in VLAN 300. Okay, I'm trying to remove that. No VLAN 300. Okay, let us see what happened to that port F0/1. Okay, it was in VLAN 300. I deleted the VLAN. Okay, see the default VLANs cannot and the reserve VLANs they cannot be deleted, but we can delete the user defined VLANs, both normal as well as extended. If you look at the VLAN now, okay, F0/1 is not here. Okay, it is moved to, okay, when once you do a reload, it will move to VLAN 1. Let us see, I'll do a reload. Still there, okay, because we save the configuration, right? We save that W, okay, sorry, we have saved the configuration actually. Okay, one thing, wait a second, I'll do something here. Okay. No VLAN 300. Okay, then I will save the configuration now. Okay, now let us do a reload or show VLAN. Okay, VLAN is removed and let us do a reload. Now let us see show VLAN. Okay. What is there? Because of running configuration, I think I saved the configuration. There is some issue maybe with the packet trace. Let us do one thing. So, see, VLAN 1 should move, right? I have deleted the VLAN and we have saved the configurations also. One second. Do one thing. Let me remove the configuration file. Okay, dir nvram. Okay. Erase startup. Okay, let us see. We erase the startup file and do a reload. Let us see now what happens. There is some problem. Okay, I'll try on some other things. It's not working. Let us see. Interface G0 by 1 by 1. Let us see. I'm going to configure, put this in some VLAN. Switch port, access VLAN. Okay, let's say 2000. Okay, created. Do show VLAN brief. Okay, G1 by 1 is in VLAN 2000. Okay. Let me remove now and see here. VLAN. Okay. Do show VLAN brief. See here it is removed. Okay. And you can see G1 by 1 is not here. Okay. It is not returned back to VLAN 1. It has to be assigned. Okay, it is in right now. It is in no VLAN. Okay, the VLAN is removed. VLAN 2000 is removed with no command, and interface is also removed from that VLAN. Now, right now it is in. Okay, not there in any VLAN. Okay, if I configure it back, I can put in switch port access VLAN 1. Show VLAN. Let us see. You can see VLAN 1 has returned to. Okay. So once it is removed, it will be in. Okay, there is a concept called bucket. Okay, bucket. Okay, that will be a temporary space for VLANs. Okay, okay, for interfaces whose VLANs are removed. Okay, right. So with this, you are done about VLAN. Okay. Now next is communication rules. Okay. See, by default,
Vijay, I have a question.
Yeah, please go ahead.
So we have VLAN range from 0 to 4095. All the
40.
VLANs will be all the VLANs will be saved in Flash, or how it is?
Flash. Okay.
Okay.
VLAN.dot all the default VLANs are already there.
Okay.
User defined VLANs are saved in VLAN.dat file.
Okay.
Yeah. The default VLANs cannot be removed, cannot be renamed. We cannot delete the default VLAN. We cannot rename the default VLAN, right? Other than the default VLANs, the user defined VLANs can be renamed, can be deleted, okay, can be updated, right? Now let us see the communication rule. For two devices to communicate, they should be by default, they should be the same VLAN, same subnet. Like example, let's say I have PC1 and PC2. Okay. And these are their VLANs, for example, say. Okay. These are their VLAN ID. Let's say PC1 is 111 default. Okay. Let's say they are class A default. They are in VLAN. Let's say both of them are in VLAN 1. Okay. Communication is possible. Yes. They will communicate. Okay. Yes. They will communicate because their VLAN and subnet both are same. Let's say the second case. There are 4 possible cases. You see. Second case. Subnet is same, but VLAN is different. They cannot communicate. Okay. Third case. VLAN is same. Subnet is different. Again, they will not communicate. Fourth case. No, see, VLAN is not assigned IP address. Interfaces are put in VLAN. Okay, interfaces are part of a VLAN. Interfaces are assigned the addresses. Okay, I'll show that after the break. Okay, we'll take a break after this, and when I come back, I will show it. Okay, the fourth one, different VLANs, different subnets. Communication not possible. By default, communication possible only same VLAN, same sub. Other combinations will not work. Like here we have same VLAN, same subnet, but different VLAN. It will not communicate. Different subnet, same VLAN also will not communicate. The fourth one anyway is not possible. Both are different. Different subnet, different VLAN also not communicate. Okay, I am going to show that practical. Okay, it's all these four cases. Okay, so we'll take a 5 to 10 minutes break. 10 minutes break. Okay, we'll come back at right now it is 9 o'clock India, 21 hours India, IST time. Okay, we'll come back after 10 minutes. We'll start again at 21:10. Okay. Okay, so I have here assigned both the port in VLAN 10. Okay, their subnet is also same, their VLAN is also same. Okay, so the default is same VLAN, same subnet, they will communicate. Okay, if they are in same subnet, same VLAN, by default they will communicate. Let us see. Okay, 10.1.1 try to ping 10.1.1.2. Okay, you can see they are able to communicate. Now I will do the second case. Same VLAN, different subnet. I'll put this in different subnet. Okay, 21.1.1. Now tell me here, anyone, if I ping 10.1.1.2, will it ping? They are in same VLAN, but different subnets. They will not ping, right? Because they are in different subnets. Okay, they will not ping. My question is, from PC3, will the packet reach here? Anyone? Anyone? Any idea why the communication doesn't happen? Okay, let me explain. See, there is no gateway. Whenever you are communicating to different networks, okay, there should be a layer 3 device. Okay, means there should be a gateway. Okay, without gateway, the packet itself will not get created. I am going to demonstrate in coming class. Okay, this one without, because that is routing part. Okay, if there is no gateway device, the packet itself will not get created. Here we have seen yesterday what is the packet, how it looks like. Source IP 10.1.1.1, source is here 20, sorry. Source in this example 21.1.1, destination is 10.1.1.2. Source MAC address, PC3 MAC address, destination MAC address requires gateway. Right? See, whenever there are in different networks, the destination MAC address should be gateway MAC address. The gateway is always a layer 3 device, a router or firewall, mostly routers, or a SVI. Because we don't have a MAC address here, gateway, so the encapsulation fails. Means the packet is not created first place. There is no question of going, the packet itself doesn't get created. Okay, is this clear, everyone? I'm going to show that practically when we start routing part. Okay, right? So you can see here from switching perspective, different VLANs. Okay, this is the case. Different subnets, same VLAN, it will not communicate. Now I'll put same VLAN, different subnets. Sorry, the other way. Okay, so I'll return it back to 10.1.1. Okay, same VLAN, same subnet. Now I'm going to change S0 by 2 VLAN. Switch port, access VLAN, let's say 20. Now we have same subnet but different VLANs. Again, they will not communicate. Let this comes up and then I'll speak. Yeah, 10.1.1, 10.2.2. Okay. Because they are in different VLANs. This is the reason. Yeah. Right. The fourth also will not communicate. Okay. Now VLANs are same. I'll change the subnet to 20. It will also not communicate. Okay. Different VLAN, different subnet, no chance. Okay. These are the four cases. Now next is how to make different VLANs communicate. Okay. In order to make two different VLANs devices from different VLANs communicate, we have two methods. Okay. It is called inter-VLAN routing. Okay. It is called inter-VLAN routing. If it is done on a L2 switch, layer 2 switch, the method used is called, we need a L3 device and the method is called router on a stick. Okay, I'm going to show that. The second one, if it is a multi-layer switch, okay, the inter-VLAN routing is done with a switch virtual interfaces. They act as a logical L3 port, not a physical port, it is a logical port. Okay, let us see one by one both of them. Okay, I'll start with the first one, L2 switch. Okay, this is our L2 switch. I'll take a new one. Okay, I can show on here also. We can see that. Let us see here. Okay, sorry, L2 switch we need, so we have to go back. Yes, there is no L2 there. L2 is here. They are multi-layer switches. Okay, this is L2 switch. I'll take two pieces. This, let's say, is in VLAN 10. This is VLAN 20. Okay, and I need a router. Okay, I'll start with two. Okay, okay, F0 by 1, I'm going to put this in VLAN 10, 10, 1, 1, 1, 20, 1, 1, 1. This is VLAN 20. Okay, interface FA0 by 1, switch port access VLAN 10. Okay, interface FA0 by 2, switch port access VLAN 20. Okay, we put the ports in different VLAN. Okay, the subnet is also different. Okay, now in order to make them communicate, there are two possibilities with L2 also. I can add this port from this router in VLAN 10, another port from the router in VLAN 20, but this is not recommended. Okay, this method of I'll repeat. See, I can achieve the task of making these devices communicate if I put one of the port in VLAN 10, other port in VLAN 20 and assign address. But on a switch, on a router, normally how many ports you have? There are 3 ports, right? For example, let's say this is a router, show IP interface brief. Okay, here on this particular model, I have 3 ports only. Imagine you have 10 VLANs. Okay, this method will not work. Okay, if you use 2 ports, where else you use the other ports, right? So this is not a recommended method, but it is possible for 1 or 2 VLANs. For 2 VLANs, it is possible. You can use this one also. Okay, let us see this one also, and then I'll show the other method, which is the one which is in use. Okay, so there are 2 ports here. I go to the router now. G0 by 0, I am going to assign one address from VLAN 10. Let's say this is 10.1.1.100. No sir, no sir. Okay, the other interface G0 by 1, I will assign another address. 21,100, 255,000, no sir. Just I'm giving the assigning the IP address. Okay. Do show IP interface brief. Okay. We have assigned 10,100 to G0/0, 21,100 to G0/1. Okay. Now next task is to put them in the VLANs. Okay. Interface FA0/3 is connected to routers G0/0 port. Okay. I'll put this in VLAN 10, and the other one FA0/4. This is connected to routers G0/1 port. I'll put that in VLAN 20. Okay. Then the next task is to go to the PCs and configure the gateway. Okay, because without gateway the packet will not be created. The encapsulation will fail. Okay, now they will communicate and reconfirm. Show VLAN brief. Okay, FA01 and 3 is in VLAN 10, 0/2 and 4 in VLAN 20. Let us confirm. Yeah, F0/1 and 3 is in VLAN 10 and these two are VLAN 20. Let me pick. Okay, from 10.1.1 to 20.1.1. Okay. See here. Okay. IP config. This is the IP address of my PC. This is the gateway. Okay. And remember always the PC and the gateway, they should be in the same subnet. Okay. First I will ping my gateway to make sure that I have reachability to the gateway. It is reachable. Now I am going to ping the other side 21.1.1. It will take some time. First packet is, as you know, an R packet. Okay. So it is drop C. They are able to communicate. Okay. But this method is not scalable. You cannot use this method when you have lot of VLANs. Okay, clear everyone? Online, is this clear? Okay. This is one method. Okay, we'll look at the second method. Okay, I'll write here and you can try to understand. Okay. I use this method, but not router and stick. I'm using individual interfaces. Okay, let us see. This is the method I use. I'm using a router, but not on a stick. I'm using individual interfaces of router. Okay, router physical interface, I would say, because that one involves logical interface. Okay, so what we did on a switch, let's say this switch one, we go to config mode and assign FA0/1. Okay, and also we assign the router port mode also, right? Router port also F0/1 and F0/3 to VLAN 10, right? One port from PC, other port from router in VLAN 10. Then we went to the other side. 2 and 4 we assigned to VLAN 20. Okay, then we went to the PC1. This is the IP address, and the gateway we configure as 100. This is the IP address of the router interface that is in VLAN 10. Okay, PC2 is 21.1.1 and the gateway is the router's other interface G0/1. This is router's 0/1 address and this is router's 0/0. Okay, so 0/0 and PC is in same VLAN, VLAN 10. Okay, and PC2 and the router 0/1 is same VLAN. Okay, so they communicate because there is gateway. Okay, on router, what we did, enable config T, then the two interfaces of router be assigned just an IP address. Okay, IP address 10.1.100 55.0.0.0, no share. That's it. The second interface, that's it. And when we ping from PC1 to PC2, it works, right? But this is not scalable. Means if you have a lot of VLANs, then you cannot use this method. Okay. So the better one is to use router and stick. Let us see this one. Router and stick, how it works. Let us see. Okay. So I'll take a new one. Again, we will take a router and a L2 switch. Okay. This is for L2 switch. For L3, we have another concept. Okay. I'll use 3 PCs, PC1, PC2, PC3 will be fine. Okay. I'll use PC3. So VLAN 10, 20, and 30, they are in different VLAN. And this one I'm going to put in a trunk link. Okay. See here. Okay. This is my plan. Gateway I'm going to configure again. Okay, already I'm giving here because I'm planning to configure this as my gateway. VLAN 20 PC2. Let's say 20.222 gateway 22 to 100. Okay. So this is VLAN 20. This is VLAN 30. Let's say 3333 3300. The gateway. Okay. First thing, on switch now. Interface FA 0/1. Switch port access VLAN 10. FA 0/3. 30. This is the command to add a port. I already, okay, you are aware of this. Okay, so I put all this in their respective VLANs. You can see here 10 is in VLAN 10, 20 VLAN 20, 30 VLAN 30. Okay, this report in their respective VLANs. Next thing, the port that is connected to the router F0/4. Okay, this is connected to router. Okay, we have to configure these as a trunk. And the command is switch port mode trunk. This is the command. Okay. The trunk link allows traffic from all VLANs by default. Okay. I'll go to the router and do the configuration of the router. Okay. I go to the router now. Okay. Interface G0/0 is connected to the switch. Okay. Connected to switch. Okay. Just on the physical interface, I'll say no shut. That's it. Okay. The physical interface, I have to say no shut. Enable the interface with no shut command. Then I am going to create sub interfaces. From the physical interface, I am going to create something called sub interfaces, a logical interfaces that use all the bandwidth, everything from the physical interface. That will share the bandwidth, other attributes of the physical interface. Okay. For each VLAN, I am going to create a separate sub interface. Okay. So create sub interfaces for each VLAN that will act as gateway. The sub interfaces will act as gateway for each VLAN. Okay. So it goes like this: G0/0, the physical interface dot. I can give any number here from 0 to 4.29 billion, but the best practice is to give the VLAN number. Okay. Anything I can use. There is no rule like that, but the best practice is to give the VLAN whatever you have configured. Okay. Encapsulation .1q VLAN 10. I put this sub interface in VLAN 10. Okay. Then I will assign IP address here 10, 1, 100, right? Is what we have configured here. That's it. A sub interface is created. do show IP interface brief. Okay, this is separate from the physical interface. See here, physical interface just no set nothing. Okay, we created a sub interface 0.10, okay, and assign an IP address. Sub interface by default they are in upstate. They depend upon the physical interface. Okay, because they are logical interfaces. Now I'll create for VLAN 20. Okay, encapsulation .1q 20 IP address 2122 we have given there, right? 2200 55000. Okay, so this is for VLAN 20. Okay, do show IP. Okay, this is for VLAN 20. Now I'll create for VLAN 30 also. Interface G0/0. This time I will not give 30, I'll give some other number. Let's say I give DJ number. Okay, there's no such rule. I can use anything. So to prove that I'm using some other number. Okay, what is important is this is important. Encapsulation important. VLAN. Okay, VLAN number. This is important. This interface I'm assigning as a gateway for VLAN 30. Okay, IP address 3300 55000. No set is not required. Do show IP interface brief. Okay, these are my interfaces, sub interfaces they are called. Okay, now let us test. Okay, router, yes, sub interface can give multi-layer switch also we can. Okay, so let me ping here IP config. This is the IP address of this particular PC and this is the subnet mask. I'm going to ping 2222 my. Okay, the first packet will be dropped. Okay, you can see that it is able to communicate. Ping 30333 will ping. Okay, right. So all the devices they can ping. PC2 also can ping PC3. Ping 30333. Okay, clear everyone? So this is called router on a stick. I'll write. Yeah. I'm going to write here. Okay. So VLANs, what we did on switch is we created 3 VLANs, right? I'll quickly write here. Enable config T. We created interface FA 0/1. Switch port access VLAN 10. Okay. Then the second port VLAN 20. So VLAN is created in the port. See, whenever I'm using this command, if the VLAN is not there, it will create the VLAN and put the port also. Yes. Similar, yeah. Okay. VLAN 30. And then F0/4 trunk link. Okay. So switch port mode trunk is the command. That's it. This is what we did on switch. The rest of the configuration was on router. On router, okay, enable config T. We enable the physical interface with a no shut command. That's it. After that, we created sub interfaces. Okay, interface G0/0 dot. After that, you can use whatever number you want. The range is from 0 to some 4.2 billion. The best practice is to use the VLAN number. Okay, encapsulation .1q 10. I will come to that. Okay, encapsulation we'll talk about tomorrow. Okay, putting on headers, okay, putting in a particular VLAN for it. Okay, IP address 10.1.100 55000. The no shade is not required for sub interfaces. They are called sub interfaces. Similarly, we create for VLAN 20 with a 2 here. Also for VLAN 30. That's it. No other configuration is required. That's it. Okay. This is our configuration for router on a stick. Now let us finish with this last topic. Yes, also right. You can do that. Range command is supported on routers also. Okay. Like suppose you want to enable multiple interfaces. Okay. Like example, you want to say no shut to more than one interface. Okay. 1 to 2, if it is there, it allows. Whatever command that is a common, you can use on router also. Okay. IP address you cannot assign right to two interfaces. Right. So whatever common command you can use the range command. Now let us see the last method for the day. Multi-layer switch. Very simple. I'll keep these as it is, same topology. Okay. Just I'll remove this part. Okay. Multi-layer switching, very simple. I'll take a multi-layer switch. Okay, already the addresses are assigned 10.11, 10.22, and 10.33. Sorry, 22 to 33.3. We will create VLANs here also. This one 50. Interface FA0/1. Switch port access VLAN 10. Okay. We can create VLAN from global configuration mode also. VLAN 20 and VLAN 30. Okay. Right. From interface or global. Interface FA0/2. Switch port access VLAN 20. Okay. This time you can see because the VLAN was already there, you will not see this message. Okay. This will see you see when you don't have a VLAN. Already we created VLAN 20 and 30. So you will not see when you assign a port. Switch port access VLAN 30. Okay, now I am going to create SVIs. Okay, how to create SVIs? We have 3 VLANs. For each VLAN, I am going to create a logical interface called SVI. Interface VLAN number. Okay, IP address 10.1.100.55.0.0.0. No shut is not required. Already you can see it is up. Okay, anyway we will give. Okay, do show IP interface brief. You can see here. Okay, SVI is created. This is L3. By default, your SVI is L3. Okay, it's a logical interface, just like a loopback. Okay, same thing we'll do for VLAN 20 also. Enter VLAN 20 is the command. Okay, then assign whatever address you want. 20 to 200 is our plan, and the subnet mask is class A. Okay, finally, enter VLAN 30. IP address 33,300 55,000. It's a logical interface. Okay. Show IP interface brief. Exclude unassigned shows only the configured interface. Okay. Now someone asked me about IP routing. Look here now. IP routing. Show IP route. If you look at the routing table, right now there is no routing table. Okay. On some switches by default, IP routing command is enabled. Okay. On this particular multi-layer switch, you can see it is not enabled, so we have to enable it. Okay, with this command. Once I type this command, now if you look at the routing table now, okay, it shows the interface. Okay, that's it. Just create 3 SVIs, whatever VLANs we have, SVI for each VLAN, and type IP routing. Okay. I'll go back here and try to ping. Okay, it will ping. Layer, yeah, multi-layer switch. SVIs. It's a layer 3 port. You cannot create that. It will not support. Okay. 30,333. You can see it is able to ping. Okay, if you test on here also. 22. So this is your SVI, it's multi-layer switch. Okay. So what we did, yes. Yeah, this is gateway. SVI is nothing but gateway. Okay, for every VLAN, SVI acts as a gateway. Okay, sub interfaces. Okay, there are also gateways for each VLAN. SVI is also gateway for each VLAN. See, whenever you are communicating two different networks, gateways is required. It could be sub interface, it could be a physical interface, or it could be a SVI. Okay, clear, Jack? Okay. Others, any questions, anyone?
So IP routing is just enabling the routing, or
Yes. Enabling the routing on the device. By default, most of the switches it is enabled. If it is not enabled, then you can create. Like example, on this switch particular model, let us see if it is enabled or not. Yeah,
Which
create an
means
SVI.
without enabling IP routing, PC1 to PC2 communication won't happen, correct?
Yes, if there is no routing table, there is no question, right?
Yeah.
Right. Without routing table, there is no communication, right? So let us see here if it is there. Do show IP route. It looks like it is already there. IP routing is enabled. Okay. Inter VLAN 10. Let us see. I'll just send an address here and see. Some number I'll give 5400.
if we have like some routing protocol configured on a switch, still IP routing is required?
Yes. Okay, without IP routing, if see by default some of the switches it is enabled. So if you look here, I did not give any command. Okay, so it is required here also. Let me do show IP interface grid. 1 second. Okay, 1 minute. Okay, the interface is down because no interface is configured. Okay, switch port access VLAN 10. No sir. Let us see. Show IP interface grid. It's still showing down. Enter VLAN 10. I think I have given this command also. Do show IP interface grid. It's not coming up. Wait. Now,
Excuse me.
Yeah. Now you can see it has come up.
Do you have VLAN 10 configured?
Yeah, I have configured. It has taken time. It will take some time. Okay. It took time to come up. Is it required to add in VLAN database? What is required to add, Pradeep? I'm not sure about this question. Can you unmute yourself?
No, actually, I was asking like, do we also need to add in the VLAN database like VLAN, then VLAN 10
yes. Because without that, it will not create, right? I have already created a VLAN, I believe. See, somewhere I have created. Okay, see here. Okay, at the time of already the VLAN was there, so you will not see any command, any message. Right now it has come up. Let us see the routing table.
Okay.
Whether we require the IP routing command or not. You look at the routing table now. Okay, it has populated. Okay, so by default on some switches it is enabled. If it is not enabled, you have to give the best practice. To give the command. What is wrong in giving one command, right? Make sure by giving this command. Okay, right? So this is called inter VLAN routing. So what we did on switch, we created VLAN for each. We created SVI for each VLAN. Okay. Assign an address 10.1.100 55.0.0.0. No share. Same thing we did for VLAN 20 and 30. Plus 22. 1030, and also we create some VLANs. Okay, so interface FA 0/1, switch port access VLAN 10. Okay. And finally, We enable the routing which is required here on this particular model by give IP routing. So this is our SPA. Okay. No, not required. See, it is not L2 switches doesn't support routing. That is why we have a router, right? Had it support that routing, then routing is not required. If it was a pure L2 switch, okay, it will not accept any L3 related command. Okay, IP routing required only on a multilayer switch. Okay, that too if it is not enabled by default. Clear, Sanjeev? Okay, so we'll stop here. Okay, so tomorrow we'll continue with some other topics like access port. We'll see trunk ports. Okay, then we'll see voice VLAN. I have kept it for tomorrow. There is a concept called private VLANs also in our syllabus for the exam. Okay, then if possible, if there's a time, then we'll do VTP also. At least we'll do VTP version. Okay. Any questions, anyone?
Can we create a sub-interface under the port channel?
Port, yes, of course you can.
Okay.
When we do port channeling, I will show that out.
Okay.
Possible. Okay. You have done. I have done many times. It is possible.
Okay. Okay.
Right. So thank you everyone. We'll continue. Can you please share a theory document and lab manual? Okay. I have to talk to management. Okay. They will send you the mail. Okay. They have kept a portal. I think I will add the documents also. Whatever I have copied here, I will share this. Okay. Whatever we have done today, the recording as well as the notepad there, I have done the configurations. You can use this one. Okay. Thank you everyone. We'll continue tomorrow. Okay?
Thank you.